Dr. Tim Still is now joining the stage with me, and he's at Schwarz IT, and he's a physical scientist who turned data scientist and who then turned AI manager. And at Schwarz IT, you are leading the AI engineering department, and your impulse is going to be about AI in the supply chain at Europe's largest retailer.
Yeah, thank you, and welcome to this talk. AI in the supply chain. I'm at Schwarz IT KG, that's part of Schwarz Group. Also, it's one of the largest corporations in Europe. Many of you, if you're not from the retail industry, may not know who we are or what scales we're talking about, and that's important for the content of this talk. So I will really briefly present who we are, who is Schwarz Group. And as I said in the title, it's Europe's largest retailer with Lidl and Kaufland, but we are more than that. We also do food production with Schwarz Produktion and removal and recycling with PreZero. On the retailing side, there is Lidl, of course. Pretty much everyone in Europe knows that. 115 billion euros in sales, more than 12,000 stores, huge number of employees. There's also Kaufland with another 30-something billion euros in sales, another 1,500 larger stores in 8 European countries. So together we are in 40 countries, I think, and another 150,000 employees. And then when we go from retail to PreZero, to our recycling company, that is not very known. That's part of Schwarz Group, but it's a big company in its own right with almost 4 billion euros in sales in 11 countries. The one thing I want to highlight is the 66 sorting and recycling facilities. So we are really big into recycling. That will be a topic later on again. And there is also Schwarz Produktion, a pretty large company that produces goods and in 15 production plants. And some numbers that I think are impressive, like almost 4 billion beverages bottled, over 2 billion bottles recycled every year. So if you buy the water of Saskia at Lidl, and I think also the K-Classic at Kaufland, it's 100% recycled, right? There is billions of baked goods, billions of ice cream. That's my favorite. So it's really a big company in its own right. And we at Schwarz IT, or especially in our department, Schwarz IT AI, we build data products for the entire Schwarz Group. So for all of these branches, and that means that we have to handle an unusually broad range of both business domains and technologies. So we're talking about brick and mortar and online retail. We're talking about shopping experience, like these frictionless shopping stores that pop up and everyone tries it out. Customer experience. Here I mainly talk about K-Card and our Lidl Plus app that we rolled out in all Europe. Logistics is a big topic. Manufacturing, that's an actual image of a product we built in Bonbach. That's our bacon factory in Schwarz Produktion. And finally, there is also a lot to do in recycling at PreZero. And that means we use the entire range of technologies that are usually considered AI, or at least in the past. So there is some deep learning, there's computer vision, there are some large language models to do some things. There's a lot of classical machine learning, especially in topics you will see today in the context of the supply chain. There is some optimization, or OR, and in terms of research collaborations, we also dived into the realm of quantum computing. It's a big topic here today. Not very big in our daily life, of course, but we are prepared if this becomes more commodity. AI in the supply chain, that's the topic today. And what is the supply chain, right? So there's this very traditional picture. Let's go from left to right. You have a customer. The customer wants to buy something and goes to the store, picks it up. The store has to order from a warehouse, and the warehouse gets the stuff from the suppliers. Actually, in our case, I could even draw further, since we are also on the supplier side. Obviously, that's a minority of the stuff that we sell, but we're also on the supplier side. Our supply chain starts with the raw materials. I will not focus on that for this talk. We're actually not doing a lot on operational products in terms of raw materials. Those are very distinct and very specific business domains, right? So what can we do and what are we doing actually in production with AI in this supply chain? One simple example is bake-off. So bake-off describes the baked goods that we sell in Lidl or Kaufland stores. And we want to make sure that our customers get the goods that they want when they want them. I'll talk about this a little bit more in a minute. Then very important use case is the automatic disposition. So from the stores, we want to order automatically, or we do order automatically at the warehouse. And that is where I will talk a little bit more about that later on. So this usually happens on the time scale of days, right? So in the store, they order every day for the next 1, 2, or 3 days, depending on the product and the country. And then, of course, the warehouse has to order with the suppliers. This is on a different time scale. So this can be days in some cases, but oftentimes it's weeks. So you have to foresee a larger amount of days here. And another thing that we optimize is logistics. And logistics is not as simple as it seems here, right? There are trucks from the warehouse to the store and from the suppliers to the warehouse. There's more to that as well. For example, we have some cross-docks. Not sure if anyone is into logistics. Cross-docks are essentially hubs or warehouses where trucks arrive from different suppliers, and then the loads are essentially reshuffled. And it's somewhat complicated, but doing that, you can save a lot of transportation. Instead of one truck bringing like 4 pallets of something to warehouse A and then another 4 pallets to warehouse B, that would be a huge waste of energy, right? So we also optimize these cross-docks, for example. On the other hand, Schwarz Group, what I showed is not everything. We also have our own container ships coming from Asia to Europe. You can look up Tailwind if you're interested. So when the container prices rose like 2 years ago during Corona, we decided that we could do this ourselves, and we have our own container ships. There you have to optimize the fill rate of the containers and how many containers you ship with our ships and how many containers you ship with other ships, and when do you do that, and do you all bring them to Rotterdam, or some to Rotterdam, some to Hamburg, things like that. So it's quite complicated logistics. There's a lot of operational research involved as well. And actually, for the customer, the story doesn't end with the chain. In terms of a circulatory process, we can even talk about a supply circle, only for specific cases, obviously. For example, in Germany, if you return your empty bottles, the water bottles, to get back your 25 cents deposit in these automats, we have to make sure that the PET, the polyethylene terephthalate, that's the polymer that the bottles are made of, come back to Schwarz Produktion or PreZero in order to be recycled. And that's in fact just one thing. PreZero, as I mentioned, they have 66 sorting facilities. We sort much more than just PET. So PET is already sorted in the machines, obviously, but all the other polymers have also to be sorted, right? They have to be sorted, and we have to know in advance how much of which polymer can we have at which time, at which facility. Not just our facilities, but also other facilities. Otherwise, we have all these chances and all these abilities to recycle, but if you don't have the raw material and cannot make sure that the raw material is there, then you have a problem. So this is forecasting, optimization combined. So 1 minute about bake-off. It's a really simple use case. So I'm glad I only used pictures, because I think in the back you cannot read anything that's written in here. It's simple, right? So you have these freshly baked bread, rolls, Dennis in the store, and what you want to make sure is that the customers get the products they want. It would be easy, you can just bake a little more than what you expect, and then you will always have shelf availability, but you will have waste. And waste here means sometimes we can give it to charity, like the Tafel, but sometimes it's just thrown away because there is no one picking it up, or we try to sell it the next day for a reduced price, but also we cannot sell everything, right? So that is really ecologically and economically, mostly ecologically actually, a really bad thing. On the other hand, if you just bake the expected value, then statistically you will have quite some unhappy customers, because statistically you will 50% of the time be below the expected value and 50% above. So we find a balance, and the way we do it is, again, demand forecasting in combination with optimization. And optimization here is a little bit more complex than in other cases, because we want to give the business the chance to set the right of goals. Okay, let's go to the bigger use case. It's the automatic disposition, and that is something that you can buy. Right? It's not that we came up with that. Automatic disposition you can buy from SAP. So there was a SAP talk 2 talks ago, for example, and we do that actually with Kaufland. So Kaufland is entirely on SAP. You can buy it from companies like Relax, Blue Yonder, and so on. It's a known problem. However, and we actually do buy from some companies for some countries. In other countries, we see some value to also develop internal IP. And that's what we did. So some countries we run with our internal auto-dispo solution. And I will talk a little bit about how we do this. Again, I said it's a known problem. It's demand forecasting at heart. And then there's optimization. Optimization here is simpler on top of that. So let's focus on the demand forecasts. You need forecasts on the level day item store. And if you think about that and the number of stores we have at Lidl, you come to numbers that are something like 10 to the 4, also 10,000 to 100,000 models, or 100,000 of different models. And you have on the order of 1 billion predictions a day for all products and for like 28 days in advance. That's what we usually do. So we can also reuse them for the ordering, the automatic ordering of the warehouses. And you need to get this scalable. And the way we get this scalable is doing 2 things. We focus first on the technical scalability. And here you need a scalable architecture. And a scalable architecture for us is a service-oriented architecture with event-driven communication that's optimized for horizontal scaling. So that obviously means something like we run it on Kubernetes in the cloud. We have auto-scaling. But the more complex part here is really, how do you optimize the databases, the read process, the input-output processes in order to be able to actually deliver 1 billion predictions in time? And then on the organizational side, you need continuous monitoring of the forecast quality, and that is super important also to gain trust. And to this end, for me, the naive baseline model in place is super important. So a naive baseline model might be like a running median or something like that. That can also serve as a fallback. If for some reason you do not trust in your machine learning prediction, you can always fall back to the simple heuristic. And to do this, we do not only do ex post monitoring, which is the straightforward part, but also ex ante monitoring. So we could switch in time to the fallback model. And then, of course, you also need, like for every complex system, a strong ops and support team. Machine learning challenges are not that manifold. When it comes to the base system, as I said, it's a known problem. You can buy it, and we do what most people in the business, I think, do. We use a tree-based algorithm. You can do other kinds of regression models as well. We spend a lot of time doing case-typical feature engineering. For example, good lag features. And I think feature engineering is and will always be an important part of machine learning for these kinds of tabular data problems. I don't think that will be ever replaced by one large foundation model that will fix it all. Just if it can be replaced, it will be not as efficient, according to no free lunch, right? And then we do quantile predictions for optimization of order amount. Some companies claim they do a full probability density function, but from all the optimizations we did, we are really fine with quantile regression. That is all we need and we don't see benefit in spending more in getting a full PDF. Edge cases that we deal with and where I think we have an advantage of internal intellectual property and internal process knowledge are, for example, certain promotion types. And sometimes they change, right? Especially with the new app, they play around, they try out different promotion types. Those are challenging for us because we don't have good training data on them. Cold start situations, always a big problem. And then we have so-called holiday stores. So a holiday store is just a regular store that has some very strong seasonality. For example, in the Mediterranean, there are some stores at the coast where you sell like 8 times more during the summer holidays than on the normal months. That is hard for a model to pick up. Okay, how does that fit into the second part of my talk? And it's a short one, AI for sustainability. I think for the bake-off case, it's obvious, but generally for automatic ordering, for supply chain, we're dealing with a lot of perishable goods. Not all of our goods are perishable, but maybe like 20, 25%. And I think it makes totally sense to think that you want to have very good predictions for the entire value chain. Otherwise, you'll have too much stock either in the warehouse or in the store, and that will eventually lead to waste. So this pays into AI for sustainability, but meet Gerd Janowski, our CEO. He says with greatness comes responsibility. That is our strong belief, and therefore, since several years now, Schwarz Group has a quite sophisticated sustainability strategy that also takes into account, and you don't have to read the details, but takes into account the different aspects of sustainability, right? It's not just energy, right? There are different aspects, and AI is helping already to solve some of them or to improve some of them. These two use cases I showed you, the bake-off and the supply chain management. Logistics I already mentioned. Later on, for example, the optimization in the cross-stocks. Then pre-zero, we improved the management of recyclables. I briefly mentioned that we optimize the planning, when will which polymer be available for which facility, but we do more stuff. For example, in the pre-zero plants and the sorting plants, we look at a lot of sensor data, and what we do is we predict clogging of the conveyor belt, which in fact is a big problem. If you've ever seen like a facility, the conveyor belts all over the place, and it's quite complex. There's no AI used to sort. This is done with infrared spectroscopy. But to predict when is a clogging, that is important because there still is a human with a broom that has to find the place and just resolve the clogging. So we can support here. Predictive maintenance, kind of a textbook use case. The one with the fridges or freezers. We also do it with our server farms, our compute centers, for example. And finally, the leaflets. It seems that we still cannot get entirely rid of the paper leaflets, but what we can do and what we are doing is trying to help to have as less as possible of them without having unhappy customers. That being said, I would summarize, supply chain is arguably the largest lever for AI improvements in brick and mortar retail, probably also in online retail, though there you have more customer interaction. Even so, for a vertically integrated group like Schwarz, we showed that improvements in the supply chain pay into sustainability goals, and there are other sustainability goals that can also and are also already resolved with AI. With that, thank you for your attention.